Steve, astonishingly modern though Darwin is to us when we read him today, we do have to remember that part of what he was doing was having arguments that maybe we don't have anymore. At least so I thought. If you read The Descent of Man and the Expression of Emotions, for example, it becomes very clear that what he's doing a lot of the time is trying to make the continuity between human and non-human animals, trying to minimize the distinctions between them. And perhaps especially in psychological respects, in the expression of the emotions. Is that a book that you feel is seminal to what you're doing?
It's a fascinating book, filled with insight, which I still write about and use in class. But it's interesting to see that he was fighting on two fronts. On the one hand, he had to satisfy his fellow biologists that he could account for biological complexity, where the eye came from and why the body is so well engineered. On the other hand, that played into the hands of the creationists of his day. So on another front, he had to point out how kludgy and maladapted many of our traits were because of their origin in animal precursors. And in the expression of the emotions, it's interesting, there is no discussion of any adaptive function of facial expressions or body postures. Now it just seems as plain as day that we wear our emotions on our face in order to broadcast signals to other people. That was not part of his explanation at all. There was an upwelling of psychic energy, a kind of hydraulic model of the nervous system that he used to explain a number of our expressions. And he even had a Lamarckian theory in there that, for example, the angry expression, where we bare our canine teeth, even though, as if unsheathing them, even though they're no longer long enough that we would have to do that. He explained as a kind of acquired habit passed on to offspring. And the reason is he was battling against a creationist of his day who offered the expressions as proof of God's existence because God gave them to us in order that we express our moral sentiments. This drove Darwin crazy. It was clear it really got his goat. And so he hammered as hard as he could on the idea that our emotional expressions are just welling up of energy. They're pushes and pulls of some mechanical model of the nervous system he had. They're holdovers of our animal past. Anything but actual signals of internal states.
That is very interesting. Do you think that some of the rather extreme hostility to evolutionary psychology is because people still are reluctant to accept the continuity between humans and non-humans? Perhaps you should begin by saying a bit about what evolutionary psychology is.
Yes, even evolutionary psychology is the attempt to offer an ultimate explanation for the way we are, the organization.
A Darwinian functional explanation. What's it good for?
Exactly. What's it good for in the sense of how did it increase the rate of reproduction of our ancestors in the kind of environment in which we evolved. So it's one of many components of a psychological explanation. To explain how why we perceive and remember and feel as we do, you have to look at the nervous system, how the brain computes it. You've got to look at how it develops in the child. But I think you also have to look at why it's organized the way it is as opposed to all the other ways it could have been organized. And that requires asking the question, what function does it serve, or did it serve in our ancestors?
When we ask such functional questions, we have to be a bit sophisticated about it. If we take a particular one, like which at first sight is difficult, like why do we enjoy music, say? How would you go about giving a functional explanation for that?
Yeah, I don't think everything has a functional explanation. In fact, it's pretty important that not everything have a functional explanation or it would be too easy. I think a proper functional explanation has to start with some kind of engineering analysis, completely independent of what we know about human beings or whatever the organism is. So let's take, for example, stereo vision, the ability to combine the images from the two eyes to get an impression of depth. One can do a bit of geometry on a piece of paper and show why it would make sense to combine the images from two cameras at slightly different vantage points. And indeed, if one were to build a robot that had to navigate an environment, it would make sense to build in stereo vision. We could look at the design specs for a stereo vision system, then bring our human being into the lab, look at how human stereo vision works, and see how well the design specs from the engineering analysis match up with what we empirically observe in humans. The closer the fit, the more confidence that we have that the function of stereo vision is to see in depth. When you don't have the engineering analysis, when you just observe that something is present in humans, it is impossible, I think, to make a proper functional or adaptationist explanation. And music might be an example. As important as music is in our lives, as much pleasure as it gives us, as much use we give it in social circumstances, it's completely unclear to me why it would have to be music that would do any of those things. Why would notes in certain rhythmic and harmonic relations be a solution to any engineering problem? And it's possible, and it's an empirical issue, that music is actually a byproduct of other adaptations. Perhaps our sensitivity to speech, a harmonically rich sound that the brain has to analyze into its frequency components in order to understand speech. Perhaps a byproduct of emotional calls that go way back in primate evolutionary history, sighs, moans, laughs, cries, and so on. Possibly a byproduct of motor control, keeping your bodily actions at a constant optimal rhythm. And maybe what music does is it combines bits and pieces of all these other parts of the brain, packs them into a supernormal stimulus, something that actually presses our buttons harder than anything in the natural environment would, and we enjoy it. At least that's another hypothesis, and it shows not everything has to be an adaptation.
Let's see if I've got that right. You're saying that in order to analyze speech, the brain has to have certain mechanisms for taking frequencies, analyzing harmonics and things. Otherwise, we couldn't tell the difference between, say, vowel sounds. I mean, the difference between ah and oo and is that's not in itself musical, but the same software mechanisms, the same brain mechanisms that you need in order to tell whether you've got an ah, an or an oo, can't help being supernormally stimulated by, say, pure tones or notes that stay the same for a long time, or harmonies, chords, harmonious chords. Is that something like what you're saying?
Yes, exactly. At least it's certainly a viable hypothesis, and I think it's more plausible than any hypothesis that tries to find some function in music.
Okay. And the sense of rhythm, would that also come from speech, or do you think that might, I mean, the enjoyment of rhythm, do you think that comes from speech, or does that come from somewhere else?
I suspect it comes more from motor control, and it is significant that as far as I know, in all cultures, people move to music. They dance, they clap, they snap, they sway, and certainly for many kinds of motor activities, there is an optimal rhythm, depending on the impedance of your body and the work. Pounding, running, scraping.
Because our limbs are sort of natural pendulums and that kind of thing.
Exactly.
Yes.
And so I think one would build into any robotic system an ability to do something at a particular rhythm, perhaps even a pleasure in finding the optimal rhythm, and it's possible that music taps into that. Now, I've got to add that people in music hate this theory.
Oh, really?
They are ultra-adaptationists, I think because of a confusion. So I think there's a confusion between adaptation in the technical sense of biology, namely a trait that, compared to alternatives, enhance the rate of reproduction of our ancestors. That's what a biologist means by an adaptation. In everyday conversation, if something's adaptive, it means it's healthy, it's valuable, it allows you to improve, it makes life worth living. And of course, music is all those things, but it's just a different sense of adaptation.
Life enhancing. Yes.
Life enhancing, exactly. Yes. And I like to say that it's a mistake to equate adaptation in the biologist sense, which is what we were just talking about, with what is worthy in life. In fact, they're often at cross purposes. So reading, for example, which is almost certainly not an adaptation, because it just appeared too recently in human evolutionary history for it to have left its mark on the genome, is one of the things that makes life worth living. It's not an adaptation. And one could argue perhaps genocide is an adaptation, that one tribe, whenever it's convenient and has the means, will wipe out another tribe that could have been selected for. And of course, that is something we detest, not life enhancing.
These theories you've been putting forward are what you might call byproduct theories, and I think it's very important not to forget about byproducts whenever we're giving adaptive explanations. It's so easy to pick on something that the animal we're looking at does and say, what's the good of that? And so often it turns out that actually that's not what's good for anything, but that the underlying mechanisms or the underlying something that's producing that thing is also producing something else. And so in this case, you're saying that music, or the enjoyment of music, is almost an inevitable byproduct of speech analyzing mechanisms. And so we've always got to think byproduct when we're dealing with adaptation explanations. And maybe that's often an answer to the many rather virulent criticisms that we get in evolutionary psychology, that the critics are not thinking byproduct, and they don't think that we're thinking byproduct. Would that be fair, do you think?
Absolutely. And in fact, I don't think one could make an argument that anything is an adaptation unless one had as an alternative an explanation such as that it's a byproduct or arose by chance. That's what gives the field its empirical content. Namely, you can test these alternative hypotheses and you might be right or you might be wrong. I mean, and they can be falsified. So an example is the hypothesis that homosexuality is an adaptation to increase the frequency of genes for homosexuality by lavishing so much care on one's nieces and nephews that it makes up for the foregone children of one's own. Now that's it's coherent. I think it's unlikely, but it's testable. You can compare gay men and straight men to see who lavishes more care on his nieces and nephews. And it turns out that gay men don't lavish more care on their nieces and nephews. So throw out that hypothesis. We don't know the cause of homosexuality, and if it does have its roots in biology, it may be a byproduct of something else. But that's an example of an adaptationist hypothesis that can be falsified. Well, they could all be falsified, and that's one that was falsified.
Yes. There is some evidence, isn't there, that homosexuality is, the variance in it is genetically determined. Do you think that evidence is good?
There certainly is good evidence that male homosexuality is partly heritable, although that could mean a lot of things. It could mean that it's a susceptibility to maternal hormones that is partly heritable. If it's heritable, it's a prerequisite for it being an adaptation, but by itself doesn't show that it's an adaptation.
Yes. When we teach about evolution, we naturally tend to focus on anatomy, but you could equally well say that psychology, that our minds are evolved organs or organ systems, couldn't you?
Well, yes, and we have every reason to believe that the mind is a product of the activity of the brain, and I happen to have one here. And it's clear that the brain is an organ. It's got an evolutionary history. All of the parts in the human brain you can find in the brain of chimpanzee and other mammals. And we also know that the brain is not just a random neural network. It's not that every neuron is just randomly connected to its neighbors, but it has quite an intricate structure. And we have reason to believe that a lot of the products of the brain, our perception, our emotions, our language, our ways of thinking, are strategies for negotiating the world, surviving, bringing up children, finding mates, negotiating relationships, deterring enemies, forming alliances, and so on. Well, why do we believe that? Well, by many criteria, the design specs for an optimal system uncannily match what we observe in human emotions. For example, in reciprocal altruism, in a computer tournament of the strategies that do well in trading favors without being exploited are almost exactly what you find for human emotions like sympathy, trust, anger, gratitude, and so on. That if one were to lay out what the computer algorithm ought to do in a competition to best take advantage of exchange of favors, and then look at empirically in social psychology studies what circumstances lead to guilt, what leads to gratitude, what leads to righteous anger. They match up very, very closely, and one can make predictions about features of human emotion that hadn't been observed before, bring people into the lab, test them, and show that people do have those traits.
Very nice. I suppose we can all easily understand why sexual lust has Darwinian survival value. And are you now saying that the mechanisms for guilt, trust, etc., those sorts of things which are mediated into reciprocal altruism, that those are a bit like lusts? I mean, there's a lust to trust, or is that not a...
Indeed. I mean, there are, and people have no problem accepting Darwinian explanations for emotions that are triggered by the physical world. Fear of heights and snakes and spiders and the dark and deep water. Disgust at bodily secretions that might be carrying parasites or rotting meat and so on. But often feel a little more surprised and even resistant to the idea that some of our moral emotions might have an evolutionary basis, like trust, like sympathy, like gratitude. But I think that as clear as it is that fear has an evolutionary basis, I think our moral emotions can be analyzed in the same way.
There's, of course, notoriously a lot of controversy about how much is predetermined by the genes and how much the mind is a blank slate, and obviously you're a protagonist in that. Do you think there are actual evolutionary Darwinian reasons for some genetic predispositions in the mind?
Well, for one thing, blank slates don't do anything, and unless there's some kind of set of motives, one can't have an intelligent system that does anything, that processes some of the input and ignores others, that treats certain inputs as reinforcers.
It's got to have some criterion for deciding when it's learning. You can't do everything by learning. There's got to be some criterion for deciding which should be taken as positive reward, which should be taken as punishment, something of that sort. That
Exactly.
At least, if nothing else, that's got to be built in.
Exactly, and also the way in which one analyzes the sensory input. You could imagine a mimicking bird that, when exposed to human speech, would be able to mindlessly reproduce the sound sequence. That's clearly not what our children do. Our children, although of course they have to take in input from the world, they have to listen to whether their community is speaking English or Japanese or Swahili. What they do in listening to those sentences is they chop it into words. They look for the grammatical regularities that group them into phrases. They don't just reproduce the sound like parrots. So there are multiple ways of learning which depend on what species you belong to.
You could imagine a continuum between having almost all learned with just a very bare minimum criterion for what to learn and building in just about everything. And I suppose people have always been a bit biased to thinking that humans rely on learning more than other species. Is it true to say that evolutionary psychologists are seeing more and more that there is rather more detail built in from the start than we had supposed?
Yes, I would argue that that's the case, which doesn't mean that humans are insensitive to input or don't engage in learning. The question is, how many different kinds of learning are there, and to what extent is each form of learning tailored to a particular problem? Do we learn to an eye for beauty in a different way than we learn the grammatical rules of our language, which in turn is different from how we learn about the physical world, like what makes objects fall and bounce and roll the way they do? So it's not, I don't see it so much as a conflict between nature and nurture, but rather fleshing out how nurture is rooted in nature. That is, what we pay attention to, what conclusions do we draw, how do we analyze the input, what motivates us. And that, I think, throws you back into nature, because you can't learn everything. A learning system has to have the machinery that allows it to learn. That machinery, I think, ultimately has to be explained in terms of evolution.
Human children uniquely learn language, and I think it's right to say, isn't it, that natural selection, or they have evolved at any rate brain mechanisms which enable them to learn language remarkably swiftly. Other species don't have that. And this leads people, linguists like you, to say that there's some deep structure which is in common between all languages. I think lay people often find that hard to believe because they hear languages sounding so very different. What does it mean to say that there's some deep commonness between all languages?
Yes. Well, in fact, I think lay people's intuitions can go in both directions, because on the one hand, you do notice the diversity across human languages, especially when you learn a second one. On the other hand, when you look at your kids and you see that by the age of 2.5 or 3, they're stringing words together into fluent grammatical sentences without having been explicitly taught. A lot of parents say, this is just a miracle. Now I know what you mean by the idea that children are wired for language. So clearly they can't be wired for words, they can't be wired for grammatical constructions, at least not the particular ones in any language. What they can be wired for is an ability to find words, an ability to ferret out the rules that combine them into meaningful phrases and sentences. And that can't be taken for granted. Just listening to speech, which is what a tape recorder can do, isn't enough to get you to produce and understand new sentences, ones that you haven't heard before. Sentences like the journalist's cliche that, when a man bites a dog, that's a newsworthy story. Fantasies like the cow jumped over the moon and the dish ran away with a spoon. Brand new combinations of words that we didn't simply memorize from our parents, but that any child can understand on first hearing and produce new ones of their own. And we see this when children start to make errors like, we holded the baby rabbits, or why did the waiter disappear, that is, make it disappear, where the children are clearly analyzing quite deeply the speech that they hear and are already showing off the talent of recombining words into grammatical combinations. They end up with an ability that matches that of their parents, and on the way, their errors show us that they're engaging in this process of grammatical analysis.
Languages differ not only in vocabulary but also in grammatical rules. I mean, German puts past participles at the end, for example. So what you're saying is that children are born with the ability not just to ferret out the words, but to make grammatical rules which won't be the particular ones, because they don't know if they're going to be brought up speaking English or French or German or Chinese. But they do have a mechanism for organizing sentences into grammatical rules which they have to get by listening to their parents and peers talking.
Exactly right.
Yeah.
Yes. So what, if anything, is innate will have to be highly abstract. And this, I think, forces us to reconsider the nature-nurture debate. I don't think there can be a debate as to whether a particular behavior is innate or selected by the forces of evolution. Whatever was selected is not going to be something that we recognize from our common sense observations of behavior. In the case of language, it's going to be something like an abstract universal grammar that doesn't correspond to the grammar of any particular language and might be pretty schematic. It might just be...
I have trouble understanding that, what that schematic abstract general grammar would look like. Since it isn't going to be any particular grammar, it'd be much nicer if all languages had the same the same grammar but just different words or something, since they are so very different.
It would, for example, it would be something that would not specify the order of subject and predicate, but might say that all languages have a subject and predicate. That would not specify the order of a verb with respect to its various objects, but say that there is a grouping of a verb with its various objects. That would not say that that suffixes stand for plural or past tense, but that words can have suffixes. So it would be highly schematic. It would not be nearly enough to speak with. It would be enough to allow the child to organize all of that sound coming out of their parents' mouths in the right ways. And so it would be rather paltry compared to the richness of any particular language. And it may not correspond to anything that a grammar school teacher would teach you. It might be even more abstract than nouns and verbs, but something like a distinction between symbols that in some languages is more nouny versus more verby kinds of words. But as long as that distinction is made, that might be all the child is need and the most that the child has to be born with.
Coming back more directly to the theme of evolution, languages, it seems to me, exhibit evolution even more directly than almost any other cultural phenomenon I can think of. You can sort of see them diverging. You can see clearly which languages are cousins and which are slightly more distant cousins and which are more distant cousins still. You can even reconstruct ancestral languages, or so I've read.
Yes, indeed.
And you're convinced by that? I mean, if somebody reconstructs Proto-Indo-European, that's a convincing reconstruction of a genuine ancestor.
Yes, indeed. And in fact, saying that the historical development of languages is like biological evolution almost gets the story backwards, because it was known before Darwin's
Yes,
time
yes,
that
yes.
languages could be grouped. And Darwin used the evolution of languages
Yes.
as his analogy for evolution of species. Namely, if you see a bunch of entities that seem to form clusters, and then the clusters form clusters, and the clusters form larger clusters, so that you can diagram their relationships in a tree. The simplest explanation is that that tree of classification is in reality a family tree. Namely, there was an ancestor, it had some offspring, they diverged, the offspring had offspring, and the reason that you have successive branchings is because you are freezing the genealogical sequence. This argument had been made quite convincingly for the Indo-European languages, as most of the languages of Europe and Western Asia. And Darwin, using that as an example familiar to the scholars of his day, said, well, that's just what happens with species.
Fascinating, yes. If we look at, say, the evolution of the mammals, we can say that there was a last common ancestor of all living mammals, and it would have been a kind of shrew-like thing way back, actually during the time of the dinosaurs. It would have been a very small, insignificant, just one species among dozens of others that could have made it, but it didn't. Is that true of a language like Proto-Indo-European? I mean, was it just a tribal language spoken in one valley somewhere in the Caucasus or something? It seems as though the grand ancestor of all European languages ought to have been spoken widely over the whole of Europe. But was it just like the little shrew in the ancestry of the mammals?
Yes, although there had to have been some cultural trait that allowed that particular tribe to wield the influence that it did. One theory is that they were Europe's first farmers, and that they simply out-reproduced the hunter-gatherers in their path, and simply had so many children's children, that they took over more and more of Europe as farmland. Another, probably better accepted hypothesis is that they were mounted. They domesticated horses and conquered large swaths of Europe and Western Asia. It's possible that both hypotheses are true of different times in their development. So there would have had to have been something. It's unlikely that it was just sheer chance, because they did manage to take over, pushing everyone, apparently but the Basques, out of Europe. But we don't know what that trait was.
So the analogy with the evolution of the mammals is even closer than I thought, because in the evolution of the mammals, you could say, well, once the rodent ancestor diverged apart from the rabbit ancestors, they never again exchanged DNA. They were forever apart. But languages surely do exchange information. Yes. I mean, English is clearly a hybrid between Germanic and Romance subfamilies of Indo-European. Doesn't that mess up the tidy story that the Proto-Indo-Europeans somehow conquered the whole of Europe with their cultural influence?
Yes, it does, and it's hard because we don't have reconstructions of contemporary language families. We don't know how much borrowing there was. And surely there was at various stages. And indeed, it's a nuisance for historical linguists trying to trace the ancestry back past Indo-European, that any time you have peoples in contact, they will exchange words and indeed sounds back and forth. Yeah. For example, the clicks in the San languages were borrowed by some of the neighboring Bantu-speaking tribes.
Yes. A few years ago, I went to a conference where there were a lot of linguists from Russia, I remember. And I said this thing about English being a hybrid between Germanic and Romance languages. I was kicked all around the room by these linguists who said, English has nothing to do with Romance, it's a pure Germanic language. And I said, but what about the vocabulary? How many of the words of English come from Romance languages? And he said, about 80%.
Yes,
but it's still a Germanic language. Can you sort of explain what he meant?
Yeah, I think the syntax of English has more in common with other Germanic languages than with Romance languages. But it is true that there's been an enormous influx of Romance vocabulary, partly because of 1066 and William the Conqueror with his Norman French taking over the aristocracy, and also because of the Renaissance and the Church, where a lot of scholarly terms and political terms and religious terms from Latin were brought in. So because of both the Latin influx and the French influx, English has a lot of of Romance. And also the syntax has changed as a result.
Yes, quite.
Because of this huge invasion of French words, which led to pronunciation changes, which led people to swallow the ends of words, which made the case endings inaudible, which then forced the syntax to be more rigid because you couldn't figure out who was doing what to whom when the case endings had been swallowed. So there's a cascade of changes initiated by the Norman invasion in 1066. That's conventionally the transition from Old English to Middle English. And Middle English was a very different language than Old English. Old English was quite similar to other Germanic languages, Middle English a lot less so.
Right. We've been talking about the reconstruction of Proto-Indo-European, which is a mind-boggling task to me. I mean, it's an astonishing thing to be able to do that. But it goes even further, doesn't it? Because having got Proto-Indo-European and Proto-Ugaric or whatever, and various other proto-languages from other parts of the world, aren't linguists even talking about using the same principles to go back even further to the ancestor of all languages?
Indeed. This is much more controversial because the trail starts to go cold after a while. If you imagine that there's a certain probability that any word will be replaced by an unrelated word, then wait long enough and 100% of the words are gone. And at that point, it's not as if there was any qualitative change in the way languages diverged. It's just that we're unfortunate enough today not to have much evidence of it. And so probably most linguists believe that beyond Indo-European, it's very, very difficult. There are more adventurous linguists who have tried, and there may even be a case of reborrowing from biology some of the quantitative techniques that have been used to try to get a signal out of the noise, to try to eke out whatever tiny bits of probabilistic information might exist in comparing word lists across languages, to let the computer push the tree backwards farther in time than Indo-European.
So do you think, just as we were talking about there being a particular tribe that spoke a particular language, that the proto-language of all modern languages was just one tribal language among many? I mean, were there lots of other languages that have left no descendants contemporary with the Ur language of all?
That's quite possible. So it's possible that there was, as linguists call it, monogenesis. That is, if there was a single group of the first modern Homo sapiens who were passed through some bottleneck and hence were within shouting distance of one another and spoke one language, it may be that all our languages are descended from theirs. On the other hand, if Homo sapiens evolved with gene flow in a number of regions, there could have been a bunch of languages and there's just no trace left of all but the one that happened to trace its lineage down to us.
Something as complicated as language could hardly have suddenly sprung into existence. It must have gone through earlier stages which were simpler, more primitive, just as any other organ evolves. Can you sort of visualize what pre-languages might have been like?
Yes, and in fact, the story of genes for language, I think, tells us that language has a complex genetic basis. There wasn't just some lucky mutation that turned an ape into a talking human. We know that because language disorders in contemporary humans, which are highly heritable, cannot all be traced to one gene. There is one gene that was identified in a particular large family, whose evolutionary history can be traced. It was present in its modern form in Neanderthals. We know this from the almost miraculous process of extracting DNA from Neanderthal bones and sequencing this particular gene. So it plays a role in articulate speech. It plays some role in grammar because people who have the mutated version of the gene have difficulty in articulating sounds, but also have difficulty in understanding complex sentences. The fact that it is present in Neanderthal suggests that it was also present in the common ancestor of modern sapiens and Neanderthals, which would push it back probably 800,000 years. But it's not the only gene that can go wrong in language disorders, which suggests that there is a complex and gradual evolutionary history to language.
So what are we talking, half a dozen genes? What sort of...
Hard to know because they may not even cleanly divide into genes that do nothing but install language and genes that prepare that part of the brain, or genes that might even foster neural growth at different stages of brain development in different parts of the brain. The fact that the relationship of genes to traits is many to many means that we may not have a clear answer to the question of how many of the genes are for language alone.
So do you think that the first individual who had this complex of genes would have been capable of speaking a language if only there'd been a language or there'd been somebody else to speak to? Or put it another way, if you had a local population of 100 people who had this gene or this complex of genes, do you think they would actually synthesize a new language sort of from scratch?
Well, the best evidence we have is what happens when you have a group of contemporary children with all of the language genes in place who are thrown together without a common language. And that can happen if you have deaf children thrown together in a community that does not have a sign language. And if no sign language is imported, say, for example, if the teachers are trying to teach them speech through hearing aids and lip reading and so on. And in that case, the children do develop a language rather quickly, within a few years, a signed language. And we know that signed languages have a syntax and a grammar and a semantics. So we certainly know that with a community of children with the modern brains, a language will develop even without much in the way of external input. So extrapolating backwards, what would have been the first language that would have developed? And here we really have to speculate. It's possible that there was a gradual transition from a manual language to a spoken language. And the fact that I'm still gesturing with my hands might even be a bit of a evolutionary holdover from that. That is that over time the ratio switched from amount of information carried by the hands to the amount of information carried by the voice, with a little bit of holdover. Today it's not 100% with the voice. And that may also account for why it's so easy for human beings to acquire signed language. It's conceivable that the signn languages were the first human languages.
I can't help feeling that, although there may be a few key genes that were necessary and that separate us off from our pre-speech ancestors, there must have been a lot of further natural selection of other genes to perfect the system and get the speech sounds and everything to exploit the possibilities offered by those key genes. I bet it took a longer time than that, and so there must have been a time when language was a lot simpler and cruder than it is now.
Yes, and the fact that this gene implicated in a speech and language disorder in its normal form is found in Neanderthals suggests that the language does have a long and complex evolutionary history. And interestingly, this particular gene, the first of, I predict, a number that will be discovered associated with language, bears the stamp of natural selection, of Darwinian selection. And the way that one can tell that is to look at how it varies at the level of the actual DNA sequence. And there are a number of statistical techniques that are being applied to distinguish genes that have been targets of selection from genes that have just gotten the way they are through random drift, such as is there more uniformity within a species in the parts of the DNA that code for protein than the ones that are not expressed or that are silent? Is there more variation between species than within species, defined in a precise statistical way? And by those tests, this gene involved in language does bear the stamp of selection, which suggests that it did something that caused it to be selectively preserved in the lineage leading to us. We don't know whether what it did was improve clarity and distinctness of speech, or ability to process complex grammatical sequences of words, or some of each, or perhaps even some of the other traits that it's been tied to, such as control of the lips and mouth in blowing and kissing and gesturing and so on. But we do know that it was selected. And I think this is a tremendously exciting discovery because it opens the door to testing hypotheses about adaptation in an entirely new way, not just by reverse engineering the trait and comparing the engineering specs to what we see in the organism, but looking directly at the DNA and saying, was this, to the extent that you can tie a trait in part to a gene, was that gene selected for, and read it right off the DNA.
That is fascinating, yes.
And by the way, by that criterion, a large portion of our genes have been selected, and in fact are even in the process of being selected. That just doing the raw statistics across our genome, not asking the question of what are these genes for or what do they do, simply do they show signs of having been selected, and a large percentage do.
Yes. If indeed over evolutionary time we have been getting better at language, that would have to mean spoken language, not written language, because writing's so recent, and so you would expect, you'd predict, that children might almost automatically learn to speak with very little difficulty, whereas they would have to be taught, and it's rather a painful process, to read and write.
Yeah, indeed. And in fact, virtually all children do acquire speech just from being exposed to it, whereas the vast majority of children have to be sent to school and given lessons in reading and writing, and even then don't all do that good a job of it. Illiteracy is a huge problem even in modern societies, as is dyslexia. Children who simply don't have the neural wiring to learn to read, even if they are quite articulate in their speech.
Yes. I still am astonished at how good we are at learning to read. I mean, it suggests that it is a byproduct of something else. I mean, the ability to learn to read and write is, in some sense, a byproduct of the ability to speak. It's just a bit more indirect, and so it does have to be, it takes longer to learn and is harder to...
Indeed, requires very much more practice and is mastered much more unevenly.
Yes. What about some more examples of behaviors or psychological dispositions in humans where we can sort of see that they probably are innate, I mean, are hardwired?
Well, I think one has a strong suspicion that's the case when people do things that aren't particularly good for them, in fact are really inexplicable in terms of just maximizing their well-being, but that have a very clear rationale in terms of what would have enhanced the survival of our ancestors. So an eye for beauty might be one of them. We all know in romantic attraction that we sometimes oughtn't be attracted to people who have a particular set of facial features. They're really not best for us, but the magnetism is very difficult to turn off. And the signs of beauty, it's been found, correspond to typical signs of fertility and health in ancestral conditions. Youth, and youth more so in men looking at women than women looking at men. And of course, youth correlates with fertility. Signs of not being infected with diseases and parasites. Signs of having a set of hormones and developmental history. Signs of tracking the ideal type in one's population, of having a set of facial features that are close to the average. All of these were predictions based on what ought to be attractive in people seeking one another, and have been shown through the computer-generated faces to really be the things that make an artificial face look beautiful. Or landscape aesthetics may be another example, where it's really not clear why we spend so much time and money and environmental damage in green lawns and gardens and landscaped front yards and parks and so on. It doesn't help our health in any straightforward way. But given that we are a species that depended on ecologically rich savanna-like environments with grass, with bodies of water, with clumps of trees, it's not surprising that these are the settings that make us feel relaxed and calm and belonging where we ought to be.
Do you think there's a danger of hindsight there, that no matter what kind of gardens we liked, we'd be able to rationalize after the fact and say, oh, well, there must have been something in our ancestral past that That
Well, there would, and one would have to test for that possibility by seeing how universal the preferences are. That is, even in cultures where the means aren't available to enjoy greenery, people, given the means, would prefer it. One would have to see if in foraging tribes there was expressed a desire to settle in the kinds of terrain that had these traits. One would have to rule out alternatives, such as that it just depended on comfortable temperature or freedom of stinging insects. So all of these are empirical hypotheses that would have to be subjected to tests. One could even see if there was heritable variation in how much people enjoyed landscapes of a certain kind. One could eventually, this is a bit of science fiction, track down the genes and see if they showed signs of selection.
Yeah. And as you're talking, I was sort of feeling, well, one of the landscapes that we find most beautiful is alpine, mountain landscapes. And sometimes we say how beautifully savage it is. And it doesn't seem obviously to fit in with the idea of an ecologically pleasant, friendly to life.
Yes,
I mean, mountains are not particularly friendly to ancestral human life, at least.
True enough. One might want to subdivide or test the hypothesis that we have. Well, one hypothesis is that we are blank slates when it comes to environmental aesthetics, and it all depends on what we grew up with. Another is that we have different kinds of reactions to landscapes. Ones that inspire awe and that give us this sense of sudden glory and appreciation versus ones that we choose to live in, and that the landscapes that are optimal for each of those reactions might differ. But it is true that whatever the hypothesis is, one wants to compare it to alternatives and do tests that distinguish them.
What about phobias, things like spiders and snakes and fear of heights and things like that?
Well, fears are another case in which what has the most emotional impact doesn't correspond with what's objectively the most dangerous in our current environment. So the fears and phobias that one sees in a modern industrial society fall in a fairly short list, and as far as we can tell are universal. Things like poisonous animals like spiders and snakes, heights, the dark, deep water, blood, social humiliation. What we don't seem to have fears and phobias for are things like driving without a seatbelt, sex without a condom, hair dryers near bathtubs, loose carpets on stairs, all of the ignominious ways of dying that claim all the
I find that comparison rather compelling, rather more so than the landscapes, actually. I mean, when you think that we know that if you're driving a car at 80 miles an hour and you slam into a wall, it's equivalent to falling from, I forget what, but you can calculate the height that it would be equivalent to falling from. And yet, I could not sit on a window ledge on the Empire State Building. I just couldn't do it. And yet, my reason tells me that I'm in exactly the same position sitting on a window ledge in the Empire State Building as I am driving a car at 80 miles an hour along the freeway. And that does seem to me to be a very important difference. We didn't have cars. We didn't have the wherewithal to travel fast on a horizontal road in our ancestral past. We very much had the wherewithal to fall off high places.
Yes, and to the extent that one can differentiate objective risks that we don't fear and ancestral risks that we do fear that are not risks in the current environment, that would support that hypothesis. Also, one could look developmentally to see if fears are acquired through unfortunate experiences, near misses, brushes with death, or whether the fears are there from childhood and just never go away. That is, do you have to learn to fear something, or do you have to unlearn your fear of something? Say for people who handle snakes, do they have to go through a training period in order to tolerate them? Or do people who fear snakes have to have had a close encounter in order to acquire the fear. And by seeing what is the default, what you don't have to learn, and what you do, one could further test the hypothesis that some fears are evolutionarily wired into us.
For what it's worth, I'm terrified of scorpions, and even if I know that a scorpion has had its sting removed, I don't think I could make myself pick it up. But when I was a child of 3, I was in Africa, and I saw this creature running across the floor, and I thought, what a nice little creature. I stuck my foot out in its way I wanted it to run over my foot, and it stung me, and I was very badly hurt, and you know, I'd like to think as an evolutionary psychologist that I would have had a built-in fear of that scorpion, but apparently in my case not.
Well, if that's the typical sequence in which fears are acquired, it would refute the hypothesis that these fears are evolutionary adaptations.
But we still have the fact that we're not afraid in the same kind of way we ought to of things like electric plugs, which are
after having gotten a shock. Yes, that would be the way to test it, indeed.
Yes. What about evolutionary psychiatry, I suppose you could call it? Is there a Darwinian explanation for mental disorders like depression and things like that?
A lot of unpleasant emotions may not be maladaptive in the sense of ultimately what was good for our ancestors in evolutionary time, or even what's good for us today. An analogy would be pain, where pain is something that obviously we'd like to have as little as possible. But people who are congenitally unable to feel pain die very young because they chew through their lips, they scald themselves with boiling hot coffee that they don't mind drinking. They fail to change positions while sitting, and so they suffer from chronic inflammation of their joints, whereas when you feel pain, you're prompted to constantly shift to allow the blood to circulate. So at first glance, you might imagine how wonderful it would be never having to feel pain, but in fact it would be quite a curse. And I suspect that might be true for some of our unpleasant emotions as well. Anxiety, which can be debilitating in high doses, in lower doses is what prompts us to finish work, to run away from an impending storm, to finish our papers on time, to prepare for a lecture or a date. Yes. Sadness, which in extreme form can lead to a debilitating depression, but in a lesser form is what allows us to value our children and our mates, and to avoid the kind of loss for which sadness is a kind of internal punishment. And a number of psychiatric disorders might be, as with chronic pain, too much of an unpleasant reaction that, when it's better modulated by environmental events, actually is necessary to human flourishing.
There's a sort of philosophical problem with pain, I think, which is we understand as Darwinians that pain is a signal, don't do that again, it's bad for you. And yet I still feel, why does it have to be so painful?
Why does it have to hurt?
Yes, why does it have to hurt?
Yes.
Why can't it be the equivalent of a red light going on in your brain that just says, alert, don't do that again, and then you just don't do it again? And I'm wondering whether it's something to do with the conflicts between alternative urges that we have, and a simple red light warning signal wouldn't be enough. We would rebel against it almost. It has to be painful. It's sort of for our own good. We're not allowed to. The freedom that a red light would give us.
Yes, you want it to be tamper-proof. That is, we wouldn't want to outsmart our own pain detectors. Well, just this once I'll drink the hot coffee, and then we might forget to turn the pain back on. And if we could rationalize our way out of things that could make a life or death difference, it may not be in our longest term interests.
A related point to that is there's a lovely quote in one of your books about you, Steven Pinker, don't happen to feel you want to have children just at the moment. And you said, if my selfish genes don't like it, my genes can go and jump in the lake. Yes. And various people have said to me, because I've said similar things, aren't you being contradictory? How can you, on the one hand, believe that selfish genes have been selected and made you what you are, and on the other hand, you can rebel against them? Isn't that a contradiction?
Yes, which it isn't. I think it's the feeling that it's a contradiction is a confusion between two different levels of analysis. In fact, two different kinds of intentionality. The idea that genes are like our motives in the sense that one can understand some of the mechanics of natural selection without having to do the sums if you temporarily imagine that the genes have motives, in particular selfish motives. That's a way of making predictions of the mechanics of evolution without having to do the math. But one mustn't confuse that with the real motives that the whole human has, the whole human being the functioning of the brain that the genes help to organize. But the brain has its desires, its motives, selfish, unselfish, which are quite distinct from the metaphorical motives that we impute to genes. So a gene that selfishly builds a brain, for example, that takes care of its relatives, something very unselfish in terms of the motives of the brain, can be selfish, at least metaphorically speaking, in terms of what the genes are accomplishing. Moreover, the genes, another way in which these can be confused is to imagine that the genes are somehow our deepest, most authentic self. That we've got our brain, and at the center of the brain there are these genes that are actually causing the brain to do what it does, which is, of course, totally false. The brain, once built, is the final arbiter. The brain is what controls the muscles and receives information from the world. And the genes have their say in their influence on the brain, but once they've wired up the brain, they can't pull the muscles directly. So if the genes build a brain that enjoys sex, that finds children cute, then if it's placed in a world in which the children under its care are not its biological relatives, as in adoption, or in which sex doesn't lead to children, as in contraception, then the brain will just do its thing. That's the best that the genes could do, is to program the brain to pursue those goals. If the world is changed so that those goals don't lead to more copies of the genes being made, there's nothing the genes can do about it. It's too late. The genes can't see the current environment directly. They act through the surrogate of the brain, which over evolutionary time, on average, wants things that would have made more copies of those genes, but may not today.
As Darwin said, I find that as clear as daylight, but unfortunately, an awful lot of people just don't get that point.
I think the metaphor of the selfish gene is, like many scientific analogies, extraordinarily useful if you remember what points of the analogy to take seriously and which ones to ignore. If you forget that, then it can be a trap for the unwary. And especially when it's combined with a kind of crude Freudian theory that many of us carry around with us, that there are the motives that we are conscious of and that we share with one another. Then there are the deep hidden motives that are much nastier and harder to get access to and we'd rather not think about. People tend to confuse that Freudian unconscious with the metaphorical motives of the genes in evolutionary theory. And that's a tremendous mistake. So that if you're nice to your kids, and being nice to your kids is a way of genes making copies of themselves, you think, well, deep down, you're really not nice after all. Deep down, you're really selfish, because that's what the genes are doing, and that's the mistake.
I agree. Do you think that evolutionary psychology can even explain why we find some things hard to understand? Like a lot of people find Darwinism itself hard to understand. Almost everybody finds quantum physics hard to understand. Can you give a kind of evolutionary spin on why we find things hard to understand?
Well, there's no guarantee that our minds will at least intuitively understand phenomena at scales of time and space that are very different from our own experience. Hundreds of millions of years, billions of light years, angstroms, where our best science tells us that the laws of reality work very differently from those at the scales at which we're used to thinking. And so disciplines like quantum mechanics and evolutionary biology and cosmology and relativity and even neuroscience might be deeply baffling. In fact, a lot of science education consists not so much of filling children's minds with new information, but debugging the information that they bring into the classroom by virtue of being human beings.
Yes.
It's very hard to think of, so even, let alone quantum mechanics and all the
Even Newtonian physics.
even Newtonian
Yes.
physics, the idea that, for example, an object left to its own
Will
devices
go on moving forever.
forever, yes.
Yes, that is very counterintuitive. And it does suggest, if this is true, it suggests that you're right about evolutionary psychology, that we come into the world with an intuitive physics, which is pre-Newtonian physics. I mean, things come to rest rather than go on forever. We understand things that move at relatively slow speeds as opposed to near the speed of light. That's why we can't understand Einstein unless we're very specially trained.
We have workarounds for all of these.
Yes.
And largely that's what that's what education consists of, namely figuring out the analogies which, when selectively applied, allow you to understand something very, very unfamiliar in terms of something that is much more familiar. So you understand evolution like pigeon breeding, only iterated
Yes.
hundreds of thousands of times, or to change your intuitions about physics by trying to imagine what it would be like to ride along a beam of light.
Yes.
It may even be that ultimately there may be domains that are permanently baffling because of the way our minds work, such as why a brain firing in patterns feels like something to the person who is that brain.
It feels subjective.
Subjective, yes, which gets back to
Well,
why
you think
pain
that
hurts.
might be another one of those. I think that's very interesting.
It's quite possible in that in areas where philosophers seem to have gone around in circles for
Yes.
thousands of years, in which every possible solution seems deeply unsatisfying, yet all the phenomena remain accounted for, there we might be running up against the limitations of what our own minds find intuitive.
If our ancestors had been in the habit of travelling near the speed of light, Einstein would be obvious. If our ancestors had been the size of neutrinos,
Yes.
quantum physics would be obvious.
Indeed.
But we live in a middle world between those extremes, and so we're limited to understanding things at that level.
And we have ways of analyzing reality that are very easily misapplied, such as thinking that evolution must be something that has a purpose, in the same way that we have a
Because
purpose.
purpose is so endemic in our human life and our social life.
Indeed, we use it to make sense of each other's behavior. Why did John just get on a bus? Well, it's not because there was some big magnet that pulled him up. It's because he wanted to get somewhere and he knew the bus would take him there, which is why he won't get on the bus if it has a slightly different number. That kind of explanation is indispensable to our common sense social life. When we misapply it to questions like, why are there humans? Why is there a planet Earth? We're apt to be misled and have to have that debugged.
Yes, very interesting. Darwin, in the expression of the emotions and in some other places, was extremely keen on the idea that we can read each other's emotions by looking at not just facial expressions, but all sorts of other things, and not just us, but dogs with their hackles raised and birds with their plumage fluffed up and things. Can you talk a bit about the expression of the emotions by non-verbal means?
Yes. The example of goosebumps is possibly the most convincing phenomenon that shows that some of our emotional reactions are evolutionary carryovers, because of course goosebumps came from the piloerection reflex, where an animal, when threatened, would make itself look bigger by fluffing up its fur. We don't have any fur, but we still have the reflex, and that's why we have the goose pimples.
That's a lovely example.
And then there are examples from our facial expressions, which Darwin pointed out. The anger expression, with the baring of the canine teeth, the raising of the corners of the lips, is like goosebumps an evolutionary carryover, because presumably it evolved from a reflex in which an animal about to attack would unsheath its canines.
Literally unsheath its weapons.
Its weapons,
and it's
yes.
become
pull,
ritualized
pull
now.
the sword out of the
Yes.
scabbard. In our case, our canines have shrunk to be in line with the rest of our teeth, so raising the corners of the mouth serves no purpose, but originated in primate reflexes that really did unsheath the weapons. And as Darwin pointed out, often our bodily and facial expressions do not necessarily prepare us for a particular course of action, but may have been the opposite display corresponding to an opposite behavioral tendency. So just as when we're angry, we stiffen up our body, especially our shoulders, we carry our arms rigidly by the sides, we make fists, we lean a little bit forward, and with the chin out and the head rigidly held in place. What bodily posture would you adopt when your underlying attitude was the opposite of a readiness to attack? Say if you were conceding or surrendering. Well, you would, body part for body part, display the opposite posture. In other words, you would shrug. And many of the facial expressions that we have also can be understood as the opposite to the display that we adopt when expressing the opposite emotion.
Some of Darwin's successors have elaborated on things like the principle of antithesis that you've just mentioned and other things to explain almost the whole of animal communication, non-human communication, that they are like Darwin's expression of the emotions. So, for example, mammals communicate by scent glands, which are a sort of ritualized versions of, say, sweat glands. The scent just happens to be there at the ancestral past, and then natural selection seizes upon it because it does, as a matter of fact, betray changes of emotion, which can be used by other animals, and therefore, and if you assume that it's useful for the sweating animal to convey the emotion, and that's a big if, but one can make the case for it, then natural selection builds special glands for making scent, which are ritualized from either sweat glands or sebaceous glands.
And the reason would be continuous with why physical motions that originally had some instrumental purpose, such as pulling the ears back to protect them in the event of a fight or unsheathing the canines, then became used simply as signals, because often in antagonistic encounters, if the outcome can be predicted in advance, it's to the advantage both of the aggressor and of the surrenderer to give up without a fight and all of the damage that would ensue if it's obvious what would happen anyway. And so you have aggressive signals which can often avert an actual fight that presumably evolved out of strictly mechanical preparation for attack or defense.
It's possible, I suppose, no, probable, that vocalization evolved as a ritualization of the breathing sounds that you can't help making. And if you're breathing heavily for emotional reasons, panting, the vocalization in evolutionary time would be an exaggeration of the sounds that are there already from breathing. I've sometimes speculated that if only we could hear each other's hearts,
Yes.
that might become ritualized. And so if we got an animal and stuck stethoscopes on them with little amplifiers for many generations, if you could do an experiment for thousands of years where every generation all animals had little stethoscopes on with amplifiers, natural selection would favor the use of these amplifying stethoscopes for communication. And then eventually you could take the stethoscopes off, and then evolution would take off in its own right without the need. You just need the stethoscope to get over the initial barrier.
Oh yes, that'd be the exact same logic, just applied to a different scenario. Probably the fact that in humans the male voice is lower than the females may have a similar explanation. The organisms vocalize in preparation of attack, and a lower voice could indicate a larger resonator. Which would be why, not just in humans, but in a number of mammals, the male has evolved ways of exaggerating the depth of the pitch of the voice in the same way that it exaggerates through beards and ruffs and posture and rearing up the size of its body. That's just another advertisement of how big and bad it is, this one done via the acoustic channel rather than the visual channel. That's an explanation of why everything is the way it is as opposed to some other way it could have been.
Steve, thank you very much. That was a fascinating conversation.
My pleasure.
Many thanks.
Thanks.